welcome you all in the 26th lecture of Electronic Measurements and Instrumentation. In this lecture, I will discuss about a transducer that is known as thermocoupler, and it converts the change in temperature into change in voltage. So, it is an active transducer because we do not need any auxiliary source for the variation to get the variation in the change in voltage. So, I will discuss this particular subject topic, that is thermocoupler, by introducing the thermocoupler, what are the basic principle of operation of thermocoupler, then type of thermocoupler, what are the different characteristic of thermocoupler, application and advantage of a thermocoupler. So, what is thermocoupler? Thermocouple is a transducer that converts thermal energy into electrical energy, and it consists of joining two wire metals from dissimilar metals to form a junction. So, we can see here there are two dissimilar metals, there are different metals which which are connected at a point that is known as junction, and when this junction get heated, if we connect a millivolt over there, the other junction, then it will show the value of the voltage generated due to the dissimilarity of the metal. So, it is constructed by joining wires made from dissimilar metals to form a junction. Voltage is produced when the temperature at the junction changes. The amount of voltage depends on the amount of temperature change and the characteristic of the metal used. The structure of the thermocouple consists of two insulated wires connected to a measuring device. Thermocouple serves as a safety and monitoring gauge for the various processes and equipments. So, here we can see that this is the two dissimilar wires, and we can measure the change in temperature in terms of change in voltage. But if we calibrate this millivolt meter in form of temperature, then we can directly measure the change in temperature. When this type of junction is used, then there are other junction which is known as cold junction. So, we use two junction, one junction whose temperature we want to measure, and the other junction is at cold junction. Generally it is kept at 0 degree temperature. So, the variation in the variation in the voltage between these two are measured by the meter. So, here is copper lead wire there, and these are the two dissimilar metal. So, why do we use thermocouple? Why not other temperature measuring devices are used? So, first of all, the temperature range. As we have seen in last lecture, that thermistor has a temperature range of minus 60 degree centigrade to 300 degree centigrade, but here the thermocouple has minus 200 degree to 2500 degree centigrade temperature variation. So, it has a very wide range of temperature change. So, depending upon the metal wire used, the thermocouple are capable of measuring of temperature from minus 200 degree to 2500 degree centigrade. So, when we want to measure the temperature of any molten metal in any chamber, then we have to use that thermocoupler. Thermocouples are also used when a satellite is launched, then a very high temperature is generated. So, that temperature can also be measured by using the thermocouple. Then robust. Thermocouples are rugged device that is immune to shock and variations and are suitable to use in hazardous environment. So, there is no variation in the reading of a thermocouple if there is a shock and vibrations are there. That is why the launching of satellite, we are using thermocouple for the measurement of temperature. When the flight takes place in aeroplane or the helicopter, we are using thermocouples to measure the temperature, because the temperature is very high. Second is very rapid response we are getting. Because of a small and low thermal capacity, thermocouples respond rapidly to temperature change, especially if the sensing junction is exposed. Means generally the sensing junction is generally kept in a uh, in a glass chamber, so that it will not be affected, but if the junction is opened or exposed, then its response, its sensitivity is very high. They can respond to rapidly changed temperature within a few hundred milliseconds. There is no self heating concept. In thermistor, thermistor get heated and then it responses, but in thermocouple, thermocouple has no self heating. So, it requires no excitation power, no auxiliary power it requires, and it is not prone to the self heating. Now, selection of a particular thermocouple. How do we select a particular thermocouple for a particular application? So, first the range of temperature range, and what are the temperature range that we want to measure. Then what are the percentage of accuracy we needed, because the thermocouple has a very wide range of temperature measure. Then it has not a very good percentage accuracy. So, we also select a particular thermocouple by deciding what range of accuracy we needed. Then in what atmospheric condition we are going to use the thermocouple, like whether it is used in a inert gases or the oxidized medium. Then level of response that expected, means how quickly we want to that the thermocouple can respond to the temperature change. Then what is the lifetime period, means for how much time we want to use it. Then check before the operation that the device is immersed in water or not, and to what level of depth, because its other junction, the one junction that is that we put in the place where we want to measure the temperature, and other junction is kept at the cold place, that is 0° temperature. So, we have to see whether the cold junction is appropriately placed or not. Then utilization of thermocouple, whether it is used in continuous we want to use it, or it is intermittent we want to use it. Then whether the thermocouple are subjected to twisting or flexing all through the device lifetime. Then working principle of thermocouple. Thermocouple working principle is based on the three discoveries, like Seebeck effect, Peltier effect and Thomson effect. So, Seebeck effect happens when the two different or unlike metals are joined together at two junctions, and the electromotive force, that is EMF, is generated at the two junction, which is different for the different type of metals. Then second is the Peltier effect, that means Peltier shows that an EMF is generated in a circuit when two dissimilar metals are joined to form two junctions due to the different temperatures of the two junctions of the circuit. Then Thomson effect, the Thomson effect is when heat is absorbed along the length of the rod whose ends are at different temperatures. The temperature of the heat is associated with the flow of current to the temperature along the rod. So, these are the three concepts given by the three researchers on which the thermocouple is working. So, the relationship between temperature difference and the generated EMF. So, the temperature of the heater element is suppose Ta, and the temperature of the cold junction is Tv. There are two type of junction, one is hot junction and another is cold junction. So, let us consider that the temperature of heater element be Ta and the temperature of cold junction will Tv. Now, the EMF generated E is equal to A Ta minus Tb plus B Ta minus Tb square. The above equation represent the parabolic function. Now, A and B are the constant whose value completely depends upon the type of material used. The approximated value of A is from 40 to 50 microvolt per degree centigrade rise in temperature. So, value of A is very high, it is 40 to 50 microvolt per degree centigrade rise in temperature, and value of B is very small and it can be neglected. So, we can neglect B, and so we can find out can be neglected if the air gap field of the permanent magnet moving coil is uniform. Means we are measuring the change in temperature in the form of change in voltage. So, we are measuring it by using permanent magnet moving coil instrument. So, if the permanent magnet moving coil instrument has uniform field, then we can neglect this B term because B term is very small, and then EMF generated E is equal to A Ta minus Tb. So, now the current flowing through heater whose temperature we want to measure is I square R. So, this means where I is the root mean square value. So, if the temperature of cold junction is maintained at room temperature like 25 degree centigrade, so the rise in temperature of the hot junction will be Ta minus Tb. So, this Ta minus Tb is equivalent to K I square R because it is proportional to I square R. So, T and then this deflection angle means we are using PMMC instrument. So, the deflection angle x in the moving coil instrument is equal to x is proportional to Ta minus Tb, and that is proportional to I square R. Since it measures I square term, so from above equation we can see that the instrument shows a square law response. So, we need an instrument that can measure the square law response of that particular temperature. Type of thermocouple. So, thermocouples are determined by the type of alloy they are used and their wires, what type of wires they are using. So, type of metal wires depends on the range of temperature to be measured. So, type of metal wires depends on the range of temperature to be measured, the environment and their mechanical strength. So, there are three types of connecting points of a thermocouple, that is exposed, ungrounded or insulated or grounded. So, the junction point that is the hot junction point, it is of three type, either it is exposed or it is grounded or it is ungrounded or insulated. So, by this we can divide it into three parts. First is exposed junction. So, as we can see, these are the exposed junctions, they are exposed, and this is the exposed B type because it is B type is there. So, these are the exposed junction type because it is not covered. So, the conductors are outside the thermocouple sheath, it is not covered, it is not in the sheath. So, these are exposed. So, they have very rapid response to temperature change, but can easily be damaged. So, if we want to measure very sensitive or very rapidly change in temperature, then we use the exposed junction thermocouples. Then second is grounded thermocouple. We can see from this figure that this type is exposed, and in grounded type it is enclosed in a chamber, it is enclosed, it is sheathed, and it is the junction point is grounded with the sheath. So, grounded type, the conductors are connected and welded to the external sheath, which forms a shield connections. Since the wire are connected to sheath, they may be since the wire is connected to the sheath, they are not insulated and may be affected by the external EMF. If there is external magnetic field are there, then it will be affected by that. So, they used to measure temperature in corrosive environment. So, this type of, when it is grounded, we can use it in the corrosive environment, and most common form of this connection is used. Then ungrounded type or insulated type. So, we can see the ungrounded or insulated type, they are not grounded, they are in the sheath. So, an insulated junction uses magnesium oxide insulating material to protect the sensor from EMF. So, this ungrounded type uses magnesium oxide insulating material, so that it will not be affected by the external EMFs. The response time is slower then the grounded or exposed junction type. So, exposed junction type is faster, then grounded type, and ungrounded type is slightly slower. They are used to protect sensitive electronics from the feedback voltage. Then thermocouple circuitry. Thermocouples, 4 type of common circuitries are used. One is average, delta, thermopile and standard single. So, average type में 2 or more, this is the average type thermocouple connection. Here this is the cold junction. So, at cold junction the thermocouples are connected and these are the measuring junctions. So, there are 4 thermocouples, more than 4 thermocouples we can use in this configuration, and then average voltage is at the meter end, the average voltage will be reached. So, average, it has 2 or more thermocouple connect parallel to the cold junction. All the resistances of all the thermocouple must be equal, then the EMF will be equal to the mean temperature of the each junction. So, we can take average of that. If the resistance of all the thermocouples, there are 4 thermocouples, if the resistance of all the thermocouples are equal, then we can take the average of this. Then there are delta connection, that is the differential connection, like this way. This is the cold junction, this is the hot junction. So, it has 2 similar wires joined to a dissimilar wire. These are the 2 similar wire and it is connected to a dissimilar wire with the measuring junction of at different temperature. Here one of the thermocouple junction must be ungrounded and have a differential measuring instrument. Then next is a standard type. It is a standard single thermocouple, like this way, standard single thermocouple. So, it uses only one thermocouple and we can measure the voltage at the different second end of the meter. Then fourth type is the thermopile type. So, in thermopile type, the thermopile has a series of the connection of thermocouples. There are many thermocouples that are connected in series, and with the EMF being the sum of each of the individual thermocouples junctions. So, like this way they are connected from starting from here, they are connected in series, and then the output of this the change in voltage is the sum of all the change in voltages of different thermocouples. Now, the voltage versus temperature relation. We can see there are different type of thermocouples. As per the material used, they are of RS type, JK type, ABC type. So, there are many type of thermocouples. So, if we see the temperature versus EMF characteristic, so here we see that R and S types are not widely used because it has a very small change in voltage. This voltage change in voltage in millivolt, so it has very small change in voltage. But if we see that E and J type, so E and J type are having a very high range of voltage change. So, when temperature changes, the high range of change in E and J. Similarly, in K slightly lesser, but K is also having a large change in millivolt, change in voltage. So, these E, J, K are most commonly used when wide range of when sensitivity is more sensitivity is required and where the temperature changes more. Similarly, when temperature changes more and if more sensitivity is not required, so we can use R and S type of thermistors, thermocouplers, sorry. So, type of thermocoupler. Thermocouple, base material thermocouple. So, type of thermocouples are base material thermocouple, that is that base material thermocouples are of following type: C type, E type, T, N, J and K type. So, these are the base material thermocouple, and these are the common thermocouple and have base material of iron, copper, nickel, platinum, rhodium and chromel. So, these are the materials that are used for the designing of or manufacturing of thermocouples. So, this is one type of thermocouple. So, T type of thermocouple. So, C type thermocouple made up of tungsten and rhenium. So, C type thermocouple made up of tungsten and rhenium, and it is used for the measurement of high temperature like 2315 degree centigrade. So, they are used in hydrogen, inert and vacuum atmosphere to prevent failure from the oxidization. So, they have protective sheets made up of molybdenum, titanium and inclone with insulators made up of alumina, hafnia and magnesium dioxide. So, C type is used for very high temperature like 2315 degree centigrade, and they are used in the vacuum atmosphere where the hydrogen or inert gases are there. So, they will not be affected by those gases. So, next is E type. So, in E type this is the basic diagram of any thermocouple, and in thermocouple the type is defined by the lead color. So, for example, the E type. So, E type is positive leg is made up of chromal, nickel and chromium alloy. So, it is made up of chromal, nickel and chromium alloy, and negative leg is made up of constantan, and they are having their leg is of red and purple. So, one leg is of purple color and other is of red colors, and it temperature range that it can measure is from minus 330 degree to 1600 degree Fahrenheit. They have excellent EMF versus temperature values, and they are used for the measurement of sub-zero temperature. If less than 0 degree temperature we want to measure, then we use the E type of thermocoupler. Then type J, it has positive leg made up of iron, negative leg made up of constantan, and they have red and white color. Temperature range that it can measure from minus 32 degree Fahrenheit to 100 degree Fahrenheit, and these are used in oxidized, vacuum, inert and reducing atmospheres. Similarly, N type thermocoupler is there. It is made up of nicrosyl and nickel chromium alloy. Negative leg, positive leg is made up of nicrosyl and other material. Similarly, negative leg is made up of nickel and other thing, and it is having a leg of red and orange color, so that we can segregate different type of thermocouples. Then temperature range, it can measure from minus 32 degree Fahrenheit to 2300 degree Fahrenheit. Similarly, there is T type whose positive leg is made up of copper, negative leg is made up of constantan, and its color is red and blue, and it can measure from minus 330 degree Fahrenheit to 700 degree Fahrenheit. Then noble metal thermocouples. So, noble metal thermocouples or platinum thermocouples, they are of B, R, S type and P type, and with very precise metal elements. They are very accurate at very high temperature, and they have a very long life span. So, B type, that is used as very extremely high temperature applications with exceptional accuracy and stability, and its temperature range is 2500 Fahrenheit to 3100 degree Fahrenheit. Similarly, R type is there. So, there are so many type of thermistors. This is a comparison chart of different type of thermistor. So, here the type is given, temperature range is given, positive leg is of which material, and the negative leg made up of the different type of material, and the color coding is there. So, these are the comparison chart of different thermocouples. Now, application of thermocouple. So, thermocouples are widely used sensor because of their wide temperature capability, ruggedness and low cost. It is found in home appliances also, industry also, electric power generation station. For the measurement of temperature we use thermocouples. We use for the maintenance of temperature of a furnace or a chamber, and we use it for the food and beverage processing, automotive sensor, aircraft engine we are using it, in rocket and spacecraft we are using the thermocouples. So, in food production this is the type of thermocouple, the set that we are using for the food production. So, this is checked by the thermocouple at any phase of production. We can use this thermocouple. So, food production thermocouple are of having two pieces, one is this piece and other is this. In the tip of the probe are two wires connected to each other. Flat headed probe measures the surface temperature. There are two type of temperature sensing device. One is the flat shape type. The flat headed probes required where we want to measure the surface temperature, and when we want to measure the internal temperature, then needle probes are used. Then extruders, in extruders also we use the thermocouple. In furnaces where we want to measure the temperature. So, this is the temperature sensor thermocouple. So, here is an standing pilot burner. So, this burner will burn the temperature, it will burn the furnace, it will start the furnace. So, the thermocouple shuts off the gas supply when it does not sense the flame. So, for the flame the standing burner is used, and when this thermocouple senses the temperature, and when there is no flow of the gases, gas supply, there is no flow of the gas, then it will cut off this the whole supply to that particular furnace. So, it restricts the gas from the building up in the furnace and make the system much safer. Then molten metal, when we want to measure the temperature of molten metal, because its temperature is very high, like 1250 degree temperature is there. So, to monitor and control the temperature of liquid metal during melt preparation, holding, degassing and casting operation, we use thermocouple. So, this type of thermocouple is used for that particular purpose, this type of thermocouple. So, this type of thermocouple is put into the molten metal and it measures the temperature of the molten metal, and when the temperature increases or decreases, it will cut the circuit. In gas appliances, the thermocouple is positioned in the middle of pilot flame. It detects the heat of the flame and generates a voltage that keeps the gas flow. If the flame goes out, if there is no flame, the thermocouple voltage disappear and close the gas valve. So, this type of thermocouple is used for this particular purpose. And gas appliances, there are two type of thermocouples we are using. One is higher pressure boiler. So, in higher pressure boiler, the two configurations are used. One is of conventional type. This type of thermocouples are used where it is pointed, and at point there is a dissimilar metal connected, and then it will sense the temperature. The second type was lens ring type. In lens ring type, the thermocouple is placed inside the ring. So, this will save the thermocouple. So, this lens ring gasket creates the seal. It creates seal for the thermocouple. It is used for mounting and access of the process of measuring. Then advantage of thermocouple, which is rugged in construction, it covers wide temperature range. Thermocouple offers good reproducibility, comparatively it is cheaper, its speed is very high, the calibration is very easily we can calibrate it. So, limitations, because it has a wide temperature range, so accuracy is less, then it is susceptible to corrosion, it is also susceptible to noise, and very complex signal conditioning is required because there is a noise generation over there. So, to segregate the required signal from the noise signal, the complex signal conditioning is required for this. So, that is the limitation. This is the comparison between RTD and thermocouple. So, RTD we use minus 200 degree to 500 degree, whereas the thermocouple we can use from 180 degree to 2320 degree. So, these are the comparison between the RTD devices and the thermocouple devices. So, that is all from my side. Thank you all.